everyone, and welcome to this exciting session in our new series of online events, AE Talks. I'm Alea at Advanced Engineering, and on behalf of the team, I would like to give a warm welcome to all of our attendees, our speakers from FlyZero and ZeroAvia, our host, Samir from ADS, and of course, huge thanks to our sponsor, Nova Systems. Before I hand over to Samir to kick off proceedings, I'll just like to quickly go over a couple of housekeeping points regarding the meeting platform so that you all know your way around. So on the right-hand side of your screen, you'll see a panel containing a chat function, a questions function, and a polls function. Please use the chat function to say hello, add comments, share tips and opinions. The more engagement, the better, so definitely don't be shy. However, for any questions, please could you ask these in the questions tab? That's the middle tab. We'll have a Q&A session at the end of Nova Systems presentation, and then a panel after Chris and Julian have presented for FlyZero and ZeroAvia. So having your questions in one place just helps us to keep them all together so we don't miss any. Now, the guys do have some polls which we'll be publishing throughout. So look out for these in the polls tab, that's the middle tab, the third tab. And remember to vote in the polls tab and not in the chat tab so that we can see the results coming in live. And then lastly, just a small thing, every time somebody writes in the chat or posts a question, you'll receive a notification sound, which can be a tiny bit distracting for you. So we always advise you just to mute your notifications by clicking the bell icon at the top of your screen. And that's it really on the housekeeping front, apart from to say enjoy the session. And I will now hand over to Samir to get things started.
Thank you, Alea. Great, thank you, and thank you for everybody for joining us. We've got well over 200 people, which is fantastic. My name's Samir Savani. I'm Head of Innovation and Engineering at a company called ADS. For those who aren't aware, ADS is the National Trade Association for the Aerospace, Space, Defence and Security Industries. I haven't got too many slides as to what ADS is all about, but please do look us up and engage with us if you're keen to join. What I wanted to talk about today was around aviation sustainability and aerospace's response to that challenge, really coming from the perspective of setting the scene for our guest speakers later on today. So a quick run through, why is sustainability the driving force behind industry and our recovery at the moment? So just walking through some of the topics. The race to zero emissions is something which is going on all around the world. And of course, with the UK hosting the COP26 summit towards the end of this year, there is huge pressure on businesses around the world, as well as in the UK, as well as governments, not least the UK government, to demonstrate and showcase what they are doing to meet the global climate goals. Closer to home in terms of aerospace and aviation, this is the year that CORSIA, the global offsetting scheme, kicks in, which places a new burden both in terms of reporting as well as costs on airlines if their emissions go above and beyond their 2019-2020 base levels. Of course, there's not much flying going on at the moment, but as aviation does recover and does regrow, those sustainability aspects will be really important because they will start adding cost into airlines and ultimately onto ticket prices. In terms of the UK, we've seen some reports from the Committee on Climate Change, that's the government's advisory board on all matters to do with climate and mitigation efforts. And that's really highlighting where aviation at the moment is perhaps a small contributor to the global climate change impact. In years to come, it could be one of the largest emitters in the sector. That's both an artifact of aviation and aerospace being quite a hard sector to decarbonize, but also from the fact that other sectors are pursuing decarbonization quite aggressively. And the third and final piece, of course, there is huge amounts of pressure, both from the public, from investors, from governments all around the world, to make sure any recovery we see in aviation is green. And it's ironic, some of those statements around how the sector itself has been instrumental in both spreading the pandemic as we see it, and also the fact that 1% of the world's population accounts for around 50% of the emissions from aviation. So those are quite some startling statistics and really places into focus the challenge we've got on our hands and the real ambition the industry has to decarbonize and improve its environmental credentials. So delivering aviation's climate change goals is the driving force behind aerospace industry, and it is the heart and center of our recovery plans. Over the past several decades, incremental improvements in aerospace products and the aviation sector's performance has been good. We have been decarbonizing as we go, But we know that that incremental improvement isn't good enough to get us onto the path to net zero 2050, which we are all determined to meet. Achieving that goal is not going to be easy. There's a whole range of complexities to consider, and I'll go into a bit more detail about those in the next couple of slides, but it involves a mix of policy, strategy, lots of technology and other solutions investments, and of course a whole range of stakeholders to make that come together. In the UK, we have taken a global leadership position, both in terms of our economy-wide perspective, where the UK was one of the first economies to commit to net zero emissions in law. And of course, the aviation industry has committed in February 2020 to make UK aviation one of the first to commit to net zero 2050 as well. So we've got huge ambition, there's huge potential there, and now is the time to align our action with that ambition. So just talking through very quickly some of the complexities, and I could easily do an entire presentation on each of these. The blue box there showing a growing public sentiment and investor pressure to make sure aviation is recovering in a green way, and that means strong and aggressive decarbonisation. If I look at the purple box, we're still unclear at what the aviation recovery scenario will look like. There are lots of predictions, but until we see flying coming back into the world, we're not going to know when we're going to meet those growth trajectories which we were so used to before going into the pandemic. Looking at the yellow box, a huge scientific and technical challenge. And the climate science around the aviation's impact on climate is still emerging. And lots of work to do to understand not just carbon's impact on aviation, but also non-CO2 effects, things like contrails. And this is a really interesting and emerging area of science that we have to keep an eye on to make sure efforts to decarbonize don't have unintended consequences elsewhere, such as contrails and water vapor. The chart with the black box around it really kind of highlights the huge challenge aviation has on its hand. Particularly from the fact that most of the carbon is in the really hard to abate segments. So 2/3 of aviation's CO2 lives in the over 1,000 nautical mile range. And that's where solutions are really hard to come by, where electrification and hydrogen will only make a small impact, and we're going to be perhaps reliant on sustainable aviation fuels going forward. But it's all to play for, and we'll hear from some of our guest speakers later today in terms of what they're doing to really stretch those boundaries. And then last but not least, in terms of the solutions we have available to us to decarbonize, genuinely there is no silver bullet. We're going to need a mix of sustainable aviation fuels, hydrogen, electrification, new aircraft, and then of course the supporting infrastructure at airports and the airspace itself to enable all of that to happen. And there is much debate in the industry at the moment as to which levers you need to pull, how hard, which gives you the most bang for buck in terms of decarbonization and environmental mitigation, and the wider economics and engineering challenges with each of those solutions. So it's a great time to be in this industry. In the UK, we have many stakeholders operating in this space, all part of the decarbonisation of aviation challenge. You may have heard of some of these with the Aerospace Technology Institute, the FlyZero project, which we'll hear a bit more about, and the ministerially led Jet Zero Council, which is trying to pave the way for the UK to have a leadership position in sustainable aviation future. So all of these areas are a little bit different, but we are all working together. And the way we're trying to bring that complex landscape together is we've started working on a UK aviation-wide net zero action plan. And this is to reflect both the kind of rising UK political ambition for the UK to be a world leader, not just to have solutions that are available to the UK, but things that we can export all around the world, create UK jobs right across the economy, right across the nation. The establishment of that Jet Zero Council could be a real opportunity to take a step change and have a real whole sector approach to the way we tackle the climate change agenda. And so what we've done at ADS is we've started to assemble this high-level action plan with the future hope that we can get all of aviation's stakeholders in the UK bought into this, so we can both decarbonise as well as create those high-value jobs and opportunities right across our aerospace industry. And with those ambitions come some real benefits. We all know in the aerospace industry that investment in the aerospace industry is an investment right across the UK, and we have to keep that up and to make sure we're investing in R&D so we benefit from the downstream manufacturing right across the country. The investment in sustainable aviation fuels is different and in some ways more exciting, but because it gives us an opportunity to create a brand new industry, which will pave the way for future hydrogen as well as future fuels right up and down the country using renewable energies to really produce zero carbon fuels to enable zero carbon aviation. So it's a really exciting time. It's a massive opportunity for the UK, and we're all going to have to work together to make it a reality. So very briefly, in summary, tackling climate change is a central and really core part of aerospace industry's mission as part of the recovery from the pandemic. UK aviation sees a growth scenario that is both commensurate with our growth agenda, but also compatible with our climate change goals. There are many complexities to overcome. I've just mentioned just a few of those around technology, but there are many others. And it's imperative that we find a way to work together to demystify, decomplexify all of that and work together to deliver those solutions. So some of our next speakers will go into that in far more detail and far more eloquently than I have. But before we do that, we'll hear from our key sponsor for today, Tim. Tim Butler is Head of Fixed Wing Flight Test at Nova Systems. And it's going to be a really interesting talk because as we introduce these new technologies to the market, the whole test and evaluation regime is going to be really important. Tim's an experimental test pilot with over 30 years military and civil flying experience. Tim's long involvement in flight test programs have given him a huge amount of knowledge and experience that's going to be really useful with tackling some of those upcoming challenges around green aviation and developing the regulatory environment that will enable that. Tim's talk will look at some of the lessons that Tim and Nova have learned over the many years around flight test campaigns. Tim, over to you.
Well, thanks very much, Samir, and thanks everyone for listening in. Hopefully you can all hear me and I've got the tech working out correctly. So first of all, I'd like to just thank the advanced engineering team for putting together this afternoon and for that great introduction from Samir. And today, Chris and Julian, as you know, are going to talk about the UK's innovation and progress in the development of zero-emission aircraft designs. But I thought it was worth taking a look at the part of the test program that can be the most expensive and time-consuming, and that is the flight test element. So in this presentation, for the next 20 minutes, I want to give you some thoughts about that elephant in the room during any design and development program, the part where you take the carefully designed and built products and put it into the hands of the testers. So I hope that the test and evaluation part of the development program, whether it's a new aircraft or a vital piece of information, this will give you some idea or some tips on how to make your test program as good as it possibly can be. So first of all, just a little bit of a recap of why do we do flight tests. Let's go back to the basics. And also here, I'll just have a look at my tech. So I've just got a poll going. If you want to have a quick look at that and maybe take a vote and just let me know what you think your area of concern is for those invested in flight tests, or for people who don't really understand what flight test might be. Where do you think that would be a difficult area for you if you were having to run a flight test program or be involved in an aircraft development? So why do we do test then? Well, we do test because in order to sell something, we need to show that it can do what the designers have promised, and that where there are regulations pertinent to the product, that it meets the regulatory requirements, and obviously where there's interaction with people is expected and the design is therefore safe. So from a top level perspective, in order to prove what the design works and will meet expectations of a customer and a scrutiny regulator, we must test the design, gather the data, and present it to the concerned parties. But testing is not just to prove that the system works. We can also use a test regime to show that a novel or innovative design can work on a smaller scale before spending lots of money on a full-scale problem. And you will see now that there's quite a few proof of concept demonstrator aircraft flying in this innovative world that we live in. We will also more than likely be using some kind of modeling in the design phase, and all this modeling needs to be validated by showing the performance of the product meets the expectations of the model. During the test activities such as bench testing, ground or flight testing, we also need to ensure that we are capturing as much data as possible to support later development, customer requirements, expectations or certification. The old adage of test once and use the data many times still holds true today, and if we miss an opportunity to use the data at every stage of development, we can add time and cost to a program. And testing can be used to help investigate and solve issues that we find during the product development lifecycle, especially in new technology programs. So overall, we need to ensure that what we have built is safe, it meets the requirements of the regulators, it does what the customers want to buy, and it does what we said it would do. That worked. So this slide then shows us that flight tests can sometimes be seen as a barrier between the design and development of a program and delivering that to the customer. This is what we call over-the-fence testing, and we try not to do that as much as we can in the modern age, and we try and get the testing done throughout the design program. And I hope to show you that a good flight test team, by taking more time as a planning at the start, can reduce overall time and cost of the test campaign. So this is my first tip: plan, plan, plan. Here at Nova Systems, we actively encourage all of our clients to think about testing you'll need to do at the outset of the program and build an integrated test and evaluation plan with the aim to try and reduce the amount of flight testing that tends to be expensive at the end of the program as much as possible. This is going to help identify areas where choices need to be made and allow decisions to be taken early to save time and money later. By having your test team understand the project from the outset, they can provide advice on where testing can occur during development, where there are likely project risks are, and where evidence can be gathered at an early stage to reduce those test requirements at the end of the project. Current specification requirements for aircraft do not fully take into account the new technologies that we are seeing developed and will be talked about later on today. And so an early understanding of the project, its design and intended use, will enable a test team to start planning the outline test processes and engage with the regulators to ensure that the right level of test and the right data is gathered at the right time to enable a smooth certification campaign. For the integrated test plan, it needs to be a living document and updated as a program advances. It will allow the team to identify sources of evidence as the design progresses and identify gaps where gaps will exist, so a targeted test plan can be put together to gather that data. And as I've already mentioned, realizing that flight tests is an expensive activity and there will be commercial pressures in any project, the more we can do to keep testing and evaluation focused and efficient, less will help save time and money in your program. So my tip number 2, don't be afraid of risk. Of course, the risk I'm referring to here is the safety of the people involved, the people over which the activity will take place, especially in aircraft testing, and the damage that could occur to the test vehicle. Over our involvement in many programs, both in the military and civil world at Nova Systems, we've seen an array of approaches to managing risk in a flight test environment. In fact, we've seen projects where assessing risk was a low priority because the test was only a quick flight, what could go wrong, to others where a dogmatic pursuit of total safety resulted in expensive measures introduced to make the project feel safer, but without addressing the source of the risk and therefore adding no real benefits. In fact, the only changes were increased time and a greatly increased cost. This matrix that you've seen here is not the typical one that you would use, but I think it quite neatly sums up the looks that I've seen on the faces when the testing requirements for aircraft have been discussed in an audience who are not experienced in conducting flight tests or managing high-risk activities. But as test professionals, we accept that the job can be risky, but we don't want to put us, our colleagues, the public, or the company reputation at risk by not appreciating the level of consequences that could occur if things go wrong. So there is a balance to be had between understanding exactly what the risk factors are and where we can provide mitigations to what will keep people and property safe and will not harm the design's reputation. The risk can be a cost driver and lead to project delays if it's not managed properly. Risk management in flight tests, like many other activities, is not just a one-time thing. It should be part of the whole test planning process and reviewed regularly to identify early areas where your mitigations might need to be acted upon. Assessing risk needs to be done realistically. There will be high-risk activities in most flight test programs, and trying to mitigate everything to as low as possible can be unrealistic, and it will add cost. As any time you assess risk with your flight test team, while there needs to be a framework around making testing as safe as you can, commercial pressures will always limit to what you can do. Of course, the safest way of undertaking any activity is not to do it at all. That's total safety. But in the world of flight tests, it's not possible to get a new aircraft designed airborne, so it takes a careful balance between managing risk, mitigations, and cost. And after all, if the mitigations are so expensive it bankrupts the company, then this is not a solution. So intelligent risk management, with the involvement and agreement of all the stakeholders at the right level of company management, will enable you to have a viable project where risks can be identified, the highest risk highlighted for close attention, and have an organisation that's comfortable with the level of risk you're willing to accept. As the project progresses, lessons will be learned that can change the level of risks that have already been identified through increased knowledge or by experience during tests. New risks can be identified or not originally foreseen, and whether you use a bow tie method of risk analysis or a matrix-based allocation of risk, you need to ensure that the stakeholder community, which includes the senior management, engineering expertise, and operation experience, are comfortable with the level of risk expected throughout the program and how that will be managed. And it's worth remembering that failure does happen. and this must be learned from and lessons applied for future activities. So there needs to be an environment where admitting failure is accepted as part of the task in your team, and no one is afraid to be open and honest about where things haven't gone as planned. To have an efficient, cost-effective and tolerably safe flight test camp program requires good planning from the outset with an involved set of stakeholders who are comfortable with how the risk is being managed by the organisation as a whole. So my next tip is around team working. Today's test flying is a highly technical activity. With the advances in zero-emission powertrains, new air traffic requirements and complex computerized systems on aircraft, one person alone cannot hope to understand every part of a system to a deep enough level of knowledge. We can see that many of the projects around sustainable aviation involve multiple specialist suppliers, from electric engine manufacturers, battery or power cell specialists, to the software experts. Everyone has a part to play in the design and test of a complex system. Some suppliers will have their own test organizations, and in today's world, some may be completely new to the airborne environment, but are specialists in their field. All the routes to gathering data for your project need to be explored to ensure that any testing you need to do on an aircraft in flight is only because you couldn't get the right data from anywhere else. Only by having a team from each stakeholder can you get the information you need to accomplish this. So while gathering data during the development process will help reduce the length of the whole system test, most of the flight test activity can only really take place towards the end of the development process, and most certification activity must take place on a representative aircraft to be valid. This means there'll be lots of test activities at the end of the program with agreed delivery dates for your customers, and nearly always some delays in the development process. Final test and certification almost always get squeezed between these seemingly immovable objects, which can add pressure to your team. And as well as end-of-line testing, it's only when a system is put under test that issues around the design or production become evident, and this tends to make the test team and test process not one of the most popular in any aircraft development activity. So we have a group of highly specialist people who are involved in a process that is not always popular, but need to work under intense pressure to tight timelines. And as much as flight test is about the technical requirements of any project, it is about the people and how they work together that really matter. By gathering a team at the early stages of the program and having a clear agreement of the roles and responsibilities within that team, relationships can be built and trust engendered amongst them. So how do you make this utopian vision of mine work? Well, it's not easy and it takes time and effort, but a well-managed and led test team who have had time to develop a good working relationship will be able to save your project a lot of time and money when the pressure is on. But just before I go on to the next slide, I need to my technology here to get the voting in. That's great. So if you can, have a look at now. I've got another poll coming up, and this is to do with technology advances in flight tests. And the poll is asking, how do you feel about integrating digital technologies into your T&E program? So if you get a chance, I'll be really pleased if you can have a look at that and let me know what you think. It's good to see there. Yep, we've got some people already having a look at that. And it's that understanding of flight test requirements that seems to be where people are concerned at the moment. So technology then, it can be useful. And the technology now available, especially digital technology, is growing at a rapid rate. Use of technology in the design and testing of an aircraft, though, is not new, and validating models through testing has been common for a very long time in aviation. But recent advances in computing and the growth in things like artificial intelligence, machine learning, and digital twinning will have an impact on how testing is conducted. Some test programs I've seen already use digital twin technology to help reduce the amount of flight tests needed, but these have mainly been in the military projects, and these concepts have yet to be embraced by civilian regulators. So it's therefore worth understanding where these tools can help and where they are not yet ready to support a program. What type of technology you want to use to gather test data needs to be considered early in the program, because it could affect the way your test program is planned, and depending on what you use, available and what is available, changes may need to be required in your process to ensure that the systems used are built into the plan and not forced in at a later date. But it's worth remembering that tech will continue to lead regulation for some time to come. And while evidence can be gathered using the latest advances in digital technology, you need to make sure that the regulators can or are willing to accept the data you provide. The digital twin idea of is the current tech at the moment. This idea that you can use modeling to predict how your system will react to inputs is catching on, but it needs a sound basis on which to sit before you can trust the results that you see. I'm sure that there will be more advances in the near future on how testing is conducted, and a greater use of some really clever ideas that are being developed will become the norm. But for any flight test project using technology at the moment, the philosophy needs to be planned into your program at an early stage. So tip number 5, hopefully you've got it by now, did I mention planning? So I hope I've dropped enough hints that having a plan for your test and evaluation efforts from the outset for the program will be key to having a successful flight test program. A plan does not need to be lengthy, in-depth or expensive activity to draw up initially, but it will pay for itself as your design development activities get underway. A good plan and a robust agreement on roles and responsibilities in a test team of the relevant stakeholders will allow you to choose the best way to gather data. It will allow you to find out early where you need to concentrate your resources. It will allow the people involved in the team to work well together, and it will highlight any areas that need addressing at the start of the project so they don't become expensive in both time and money when you need to be delivering to your customers. The integrated test plan should be a living document, and there will be changes in the development process and experiences that you're going to need to incorporate along the way. And you need to do this to ensure your plan reflects the latest information available. As flight testers, it might seem a little strange that we're advocating an early test planning in a way to reduce the amount of physical flying that we need to do. After all, pilots are there to fly airplanes. But as a commercially experienced test pilot, I understand that the business of delivering a product on time and to budget is what we all want to achieve. And if we can do that by minimizing the exposure to costly test activities, then we all win in the relationship. So just to recap, an early integrated test and evaluation plan will help set the scene for the test program and the test team from the outset. Use the risk analysis to help inform the stakeholders of where most risk lies, but accept that there will be a balance of risk against cost, and this must be accepted by the senior team. Get your team together early to build the relationships that will ensure that they can work together when their program is under a lot of pressure. And use technology as much as you can, but be sure to plan how it will be used and that the results will be acceptable to your customers and to the regulators. And don't forget, have a plan. So how does this work in practice? Well, what I've done is a project that we worked on last summer. We use this process, and I hope I can prove or show to you that by doing this, you can save time and money in your flight test program. So what do we do? Well, in late July last year, Nova Systems and our Part 21 sister company GVH were approached to support a flight test campaign in Memphis in the USA. WheelTug, an innovative company that have developed an electrical drive nose wheel device to reduce ground handling requirements, were running a demonstration of the system in September at Memphis International. As part of the process to gain certification of the device, some baseline flight test was needed. Unfortunately, no integrated test plan had been developed, and with a month to go, it was discovered that the US test company contracted to fly the aircraft did not have the correct permissions to operate a Spanish registered aircraft in the USA under a Part 21 permit to fly. And as we had the correct approvals, we were asked to step in. So on this slide, again, with the use of technology, there's no one's safe when you're doing flight tests nowadays. This is one of the test flights that was conducted over in Memphis, seen by some of the guys in Spain who own the aircraft. So what did we do then? So the first thing we did at Nova was to take a look at all the available data and come up with an initial plan. We realized that some of the test points were going to be very demanding, and there was a significant risk of damaging the aircraft if the test points were flown as requested by the design engineers. The requirement, in fact, was to land on all 3 landing gear at the same time at differing rates of descent to gather some data for them. But this could run the risk of landing on the nose wheel first, and that's something for which the aircraft is not designed to cope with. We also identified that the airfield plan for the test, in this case Millington Airfield, which is to the north of Memphis, did not have a long enough runway to do the necessitated tests without having to have long break cooling times between each run and increased risk of runway overrun. So we had to look for somewhere else. And finally, we had to figure out how to get to Memphis in the middle of a COVID pandemic. So we engaged the stakeholders. Firstly, we discussed the test requirements with the design agency to see if there was a way we could adjust the test to mitigate the risk. And we talked to some Boeing test pilots for their thoughts, and then we came up with a new plan. Next, we engaged with the aircraft owners. Until this point, they hadn't been involved in the test process and they had no flight test experience. We explained what was involved and the requirements that we needed, But this highlighted an issue with the aircraft insurance that we were able to resolve before the test took place. And having understood the requirements and spoken to the other pilots, we identified the main risks and came up with a plan to mitigate them as much as possible. And here we used technology to help us, in this case, a level D full flight simulator of the aircraft. So while we were keen to use the simulator to allow us to test our theories and see how practical our solutions would be, we realized that any simulation is only as good as a flight model that it's based on. And for almost all Boeing 737s and probably all Boeing 777 simulators, there will be no accurate modeling of the aerodynamic effects of the aircraft conducting a 3-point landing in ground effect. However, recognizing that this would not give a perfect answer, we were happy that it was the best way to understand the risk and to see what solutions might be possible. And finally, we spoke to Memphis International about using their airport, and this was agreed with the time limitations due to traffic movements. It's a FedEx hub, but they have an 11,000 foot runway, which is much better than the just under 8,000 foot that we originally had at Millington. So we had a plan for the additional time, and then, we had a plan for the additional time to get the visas required for travel, and then we flew out to Memphis, or indeed I did. So in the end, the original plan had been for a 5-day test window with 4 flights planned over 10 hours to gather the data. But by using the test planning process, we were able to put together a plan that would identify risks and kept it updated, and we delivered the test campaign in 3 days over 3 flights using 7 flight hours. We gathered sufficient data for the design house to declare the campaign a success. And now, because I have been talking for far too long, and you're probably getting a little bit bored with the sound of my voice, and of course I'm a pilot, I'm going to show you a little video of what it is that we were trying to do. This is a video then of us holding on, trying to hold the aircraft above the runway, and then land with the main gear and nose wear as close together as possible. This didn't quite make it on this approach.
Minimum. 50, 40, 30, 20, 10.
Okay, thanks for that, Charlie. So thanks very much for listening to that. The poll results are in. I didn't realize I could get to say that. That's great. It looks like then how do you feel about integrating digital technologies? And most people are in the process of digitizing many aspects of their test campaigns, and that's really good because that is the future and it will save people time and money. And your greatest concern is the lack of understanding of testing requirements. And I think that can be solved, as I said, by getting your test teams involved early in the process so they can help people understand the requirements and get the plan in place. So thanks very much for listening. Over to you, Samir, now, and I think it's the Q&A session.
Hi, thanks for that, Tim. Really interesting presentation. Thank you so much for that. And really just picking up on the question of digital and how far we can go with the use of digital technology. So looking at the poll results, it looks like, about 3/4 of the community out there are already using digital means as part of their test regimes, or are looking to do so, with about 1/4 not seeing it as a priority, or perhaps have a bit of trepidation. So I guess the question, and sort of amplifying the question that was put on the question box actually, in terms of digital modeling and technologies, how do you kind of see these coming into the test and evaluation process over the next few years? Are we going to see a lot more of the technologies like you're talking about, digital twinning? And just how far do you think we can go with digital versus physical?
I certainly think that there will be a growth in the digital involvement in flight tests over the coming years. And we're looking at that currently in Nova with a couple of projects that we're working on how we go about doing that. You're right, it is the way ahead. We might as well make use of technology that we have and the increased computer power and the new algorithms that are being introduced. But there's always going to be a need at some point to prove that these are correct. So I think in whatever flight test process we have, there's going to be an increased use of the digitization, and that'll be a good thing. But we need to understand the limits of what it can show us, and also how we go about validating that with the minimum amount of flight tests needed. So there's a middle ground plan to be had there. And as I said in the presentation, this is also going to be a journey for the regulators as well, because there's a lot of skepticism, I think, within the regulators about how much digitization and digital data you can use when you're talking about aircraft safety, especially when you're putting people on board aircraft, and guaranteeing their safety to the levels required under current civil regs.
No, and I guess that was my follow-on question, Tim, in terms of how you are finding working with the regulators around the world, from what it sounds like. But do you see the UK CAA in terms of its regulatory and certification regime being forward-leaning, or are they a bit more conservative? How would you rate them?
I think the issue right now for the UK CAA is, having just left the EASA, we're in an area where there's some gaps to be filled. Now, as you know, well, under EASA, most of the certification work was done out of EASA itself, and most of the people were out in Munich and doing this work. So to bring all that back in-house, I know that the CAA are working hard to get themselves to a level where they can take on all the regulatory work that EASA used to do. But I think for the moment, there's probably going to be a little bit of conservatism while they get their baseline sorted out. But I'm hoping that, given the inputs we've had from government and through organisations like yours and Chris and Julian's, that they're going to be forward-leaning to help us get an advantage in the new technology that we're looking at, and the net zero aviation that we want to be in. I think we have to be forward-leaning if we want to get an advantage over the rest of the world.
Thank you so much for that, Tim. There are a couple of other questions on the question box, so I'm wondering if you can have a look at those and maybe get back in writing in response to some of those. My apologies that we haven't been able to go through all of them in any great detail, but hopefully, Tim, you can get back to some of those with some responses. Some couple of interesting questions coming through there directly related to your presentation.
Okay, yep, I'll certainly do that. And thanks very much. Thanks again.
Thank you. Right, so we're about to hear from our next speaker, Chris Gear, who's a project director for FlyZero. Chris has led major strategic projects, including in the areas of disruptive and novel technologies, and has a huge deal of experience in the aerospace industry. That vast experience covers many aspects of what Chris is now involved with the FlyZero project, which we'll hear about shortly. So his talk is going to cover not just an introduction to this flagship UK project, but also the opportunity for industry and for the supply chain to get involved. Chris and the other speakers' full biogs are available on the AE Talks website, so I invite you to have a look there. But without much delay, over to you, Chris.
Thank you, Samir. So good afternoon. My name is Chris Gear. I'm the project director of FlyZero, which is a very great honour to represent FlyZero in the ATI and what we're trying to do in the UK. So I'm going to take you through our plans and where we come from and where we're going, so that you can all get a feel for what we're up to. But our challenge is clear, and that's to remain sustainable. And for the UK to meet its carbon commitments, aviation must radically reduce its greenhouse gas emissions. So as I go through this, I will have 2 poll questions for you to look at, and I think they're already available to see. So as I go through, make your own minds up and decide how you want to vote. One of those is on a zero carbon flight from London to Rome in 2030, which is one of the quests that I have. And the other one is trying to determine, what do you think the fuel system or fuel type might be that we would look at when we go forward. So without further ado, so I think, if you look at the challenges, the environmental impact of aviation is the single biggest challenge for the sector in the long term as we look beyond recovery from COVID-19. If you look at the global CO2 emissions from aviation, there's approximately 885 million tons per year put into the atmosphere, which is about 2% of global emissions is down to aviation. And last year there was a report done by David Lee et al. That showed that all impacts are taken into account. Aviation represents about 3.5% of the warming impact caused by humans. So you may not think that's significant, but it is a large number. And the Paris Climate Agreement to limit global warming to well below 2%, preferably to 1.5 degrees Celsius compared to pre-industrial levels. So again, the challenge is on there. June 2019, the UK government set a target for the UK to bring all greenhouse gas emissions to net zero by 2050. And in December 2020, the government set a target to reduce the UK emissions by at least 68% by 2030 compared to 1990 levels. A challenge, yes, but it also represents an opportunity to bring forward new technologies that deliver both environmental gains and economic returns for the UK, a market that is said could be worth £4 trillion globally by 2050. This then is a defining moment in the history of aviation, akin to the advent of the jet age, and the race is on to create a new generation of truly sustainable aircraft. And if you look at that, this is to protect our planet for future generations and meet our commitments to flight change and climate change. And we need a step change in the design, manufacture, and operation of commercial vehicles. This new breed of aircraft will call for entirely new design, engineering, and industrial capabilities, which will lay the foundations for the future of the industry and its supply chain. Just as investments made 40 to 50 years ago set up the aerospace industry we know today. Being at the leading edge of these new technologies is vital to the UK's future competitiveness in the entire civil aerospace market, as international competition in this area intensifies, and truly it is global nowadays. So again, looking at those polls, have a look to see what you think you would vote in terms of the questions. So what is FlyZero? So backed by the UK government, the Aerospace Technology Institute is leading a project called FlyZero. It's bringing experts together for an intensive 12-month research program. Our vision is to realize zero carbon emission commercial flight by the end of the decade. We are taking a detailed and holistic look at the future of zero carbon aviation, from propulsion to regulation policies, systems to supply chains, and economics to environment. We are assessing not only the technical challenges we face, but also the sustainability issues, the UK industrial capability, and the market and economic aspects. The output of the FlyZero project will shape the future of global aviation with the intention of gearing up the UK to stand at the forefront of sustainable flight in design, manufacture, and skills for years to come. Part of what FlyZero will create will be knowledge capture within the individuals involved with FlyZero that hopefully will be retained and anchored in the UK. If we look at the journey so far, FlyZero journey started a year ago now, with discussions between the ATI and BAES on how to address the challenge of radically reducing aviation-related carbon emissions. Those discussions culminated in FlyZero being announced by the Business Secretary and COP26 President Sharma at the Farnborough Virtual Air Show in July 2020. Then in November, the government unveiled a 10-point plan for a green industrial revolution, which featured FlyZero. I joined this program sometime at the end of October, and in January, I was pleased to welcome my leadership team with colleagues from Airbus, Rolls-Royce, GKN, Spirit, Aerosystems, and the MTC Catapult, and the ATI, as well as 2 independent people. And this team is what's leading FlyZero today. And this month, in February, we welcomed another 20 new team members from companies including EasyJet, NATS, GE Aviation, Mott MacDonald, and Belcam to the team. And we are still continuing to grow our team and still continuing to grow the company supporting our team. So what is our project? Well, our project is a 3-phase project. With this team in place, we're able to make real progress. And as you can see here, there are 3 distinct phases of the program. The first one is gathering the facts to understand what's currently possible, as well as what propulsion system, fuel types, and airframes offer the best chance of success. This will involve looking at what's already out there, so I'm looking forward to hearing from Julian on ZeroAvia in a few minutes. But it's also looking at what's not out there and looking at, in an independent approach, what might be a solution. So we started to create technology and commercial models which will help us to identify future UK infrastructure requirements in both manufacturing and operations. And our outputs is to produce detailed models for 2 zero carbon emission aircraft concepts, which will be different, but will support the theme of zero carbon emissions. And we'll create the roadmaps, not only the technical roadmaps, but the business and economical business cases for future UK investments. We'll look at identifying any dependencies on future policy or legislation to ensure that we can at least capture all the known questions that we need to address to put one of these aircraft into service. And clearly we need to move at pace. And I can already tell you that my team, which is around 30 and will grow to in the region of 50 in March, is already tackling some of these major questions using some unique and novel agile approaches and sprints. We've already run cases around hydrogen combustion, hydrogen fuel cells, battery electric, alternative zero carbon fuels, and big picture cost models. So we're well into the process of starting to develop those studies and looking at the concepts. And when I look at where I'm going to study and what FlyZero is going to focus on, we're going to focus on some of the harder questions, because we know down at the lower electric vehicle areas, there's a well-developed route to get to a solution that can fly a reasonable distance and carry a small number of passengers. And at the bigger aircraft, we know that sustainable aviation fuels is the key to that market and will continue to be. We're going to be in the middle, where there's the variation from going from fully electric to a fully hybrid hydrogen or electrical energy system. So our focus is going to be on the single aisle, the regional, and the sub-regional aircraft. While we'll be looking to eVTOLs and sustainable aviation fuels as part of the project fact-finding, this isn't the market our aircraft concept will cater for. The concepts are all likely to change, so I'm just showing you an indicator in these pictures, but we're really going to look at what does the market sector look like if you convert our existing aircraft to a different energy propulsion system. What does it do to the range? What does it do to the payload capability? And also, what does it do to the infrastructure around the airports and in the various countries? So we'll be looking at those trade-offs, and we'll consider the power to weight ratio, the payload, noise, energy storage, and configuration. Alongside this, we'll be running cost models to ensure our concepts are economically viable in the future market. As I touched on in my introduction, FlyZero is more than identifying the best fuel type, propulsion system, or airframe design. We want the outcome to help the UK aviation sector to stand at the forefront of sustainable flight in design, manufacturing, technology, and skills for years to come. Here you can see some of the tangible deliverables my team will be working towards in the coming months. The concept designs will be a vehicle to help us explore the technology, manufacturing and skills, and supply chains. We'll need to either bring these to fruition or maximize the potential benefit of the future zero carbon airspace market. So if we go and look at the polls for a minute, just to see what people are thinking. And I don't know if you've all managed to vote, but I think a lot of you are supporting the idea that we can fly from London to Rome on a 100-seater by 2030. And interesting enough, you're all placing your bets on terms of what type of fuel that would be. And I don't blame you for doing that. I think the fuels are quite a challenge and quite different than what we deal with on our normal day lives. And I think it'll be interesting to see what the outcome of FlyZero will give. But I also think FlyZero will challenge the sort of present paradigm that all fuel systems are equal. I think hybrids and that might become stronger. Okay, so just to sort of close off then. So if you want to get involved, we're keen to get people involved. We're still looking for secondments into FlyZero's team, so talk to us about those opportunities. We're inviting businesses of all sizes to talk to us about secondment opportunities. We should not only support the project, but also give you the opportunity to work as part of an unrivaled range of experts and knowledge in our industry. Individual applications are also open, so please visit our website to find out more and apply now. As the project evolves, we'll be posing We'll be posing questions to organizations with expertise we need input from, perhaps on a short-term engagement. And academia, we're going to be putting research questions into academia to tap into the world-leading knowledge and research capabilities we have here in the UK. Our outputs are, our aspirations is for the outputs of FlyZero to support the UK aviation sector as a whole, prepared to be a key player in the next generation of sustainable flights, so we'll be making all findings and recommendations available. To support this, we'll be hosting webinars throughout the project, so please do register for these. And of course, you can visit our webpage and follow the ATI social channels for the latest on FlyZero. And finally, reflecting. The challenge is clear. To remain sustainable and for the UK to meet its carbon commitments, aviation must radically reduce its greenhouse gas emissions. The time to act is now. We are in a race to create the next generation of zero carbon emission aircraft and secure a share of the economic benefits this will bring. This is a major opportunity for UK engineering. FlyZero will help the UK stand at that forefront of sustainable aviation, and it's key that we pass this information back to the UK industry and actually embed it in our people and capabilities in the UK. Just like to say thank you to Bays and colleagues in the ATI and you in the audience for your support to FlyZero so far, and I look forward to working with you in the coming months. Thank you.
Thank you for that, Chris. Really great overview, and I know the team is working hard to kind of accelerate this program. We've got a year or 9 months, as I measure it, left to really produce some really great output. So I can see a couple of questions already coming through, and we'll save that for the panel debate, but really encouraging the audience to keep on passing those questions on to us, and we'll tackle as many of them as we can in the panel debate with Chris and Julian later on. Without much further ado, I'd like to introduce our next speaker, Julian Renz. He's Head of Business Development and Project Manager at ZeroAvia. So Julian is Head of Programs at ZeroAvia. The company itself is a world leader in hydrogen electric zero emissions aviation, and is currently flying the world's largest hydrogen electric aircraft right here out of the UK in Cranfield, so that's fantastic. Prior to joining ZeroAvia, Julian led project teams at Systemic, which is a sustainability-focused investment and advisory firm. And again, as I mentioned, the full biographies of all of our speakers today are available on the AE Talks website, so I invite you to have a look and get in touch with the speakers outside of this forum as well. Without much further ado, over to you, Julian.
Sorry for the delay here, everyone. We're just having a little technical hitch with Julian joining, but he'll be with us as soon as possible. We're just trying to get him on stage now. Bear with us, please.
There we go. Now you can hear me, right?
Yes, we can. We can see you there, Julian. I'll hand the presentation, the stage back to you. Thank you.
Thanks. Apparently, I had to join stage actively and not be dragged onto stage, as is usually the case. And well, thank you all. Well, thanks A for the invitation, B for the lovely introduction from Samir and Chris, and clearly for all of you believing in hydrogen fuel cells as most likely to be used to power flight. So clearly come here preaching to the choir, but I'm in any case quite excited about it. And I'm excited about it because of a very specific reason, and I kind of like to start my talks with my little cousin, who's called Helen, and she was born last year. And what that means is that this young woman will experience all the fun advanced engineering that all these talks here are about. And I always find it quite interesting to actually think about what does it mean for her life, right? She was born in 2020, and she will grow up throughout the century. By 2050, she'll be 30 years old, just to give you an idea. And what I like to do is I like to do a few bets with the audience, usually, to start off. Because Helen is living a life impacted by all the technologies that we're developing, and I'll make a few bets on that. And you can bet with me or bet against me, but what I'm really curious about is just the crowd that we have in the room today. What kind of interests or what kind of faith in the future, I should say, they have. So let me start with my very first bet. My first bet is that Helen, by the age when she would learn how to 10-finger type on a keyboard, actually won't do that anymore. I think there will be other means of interacting with computers and stuff like that that will not be a keyboard. So my first bet is Helen will never learn how to type a keyboard. And now you have a little poll question there, where you can either push yes if you want to bet against me, or no if you believe in what I have just said. So let me see your answers. And despite us being here at Advanced Engineering, there's clearly 2/3 roughly that actually don't believe in what I have just said. So that's okay. I hope that you can all, pay a beer for me at some point, buy me a pint when that's possible again. So that's good. Let me get to my second bet. My second bet is that Helen, by the time she would learn how to drive a car, actually won't do that anymore. I think she will never learn how to drive a car. You want to bet with me or against me? And surprisingly, actually, it seems to be a higher number that doesn't believe in autonomous cars than there is in kind of speech recognition and so on. So that's interesting as well. And then you see where this is going, right? Like we just went through, 2025, 2030 maybe, when Helen is 5 to 10. Now we're at 2038, when she's 18. And now we're moving into 2050, when Helen is 30, when she's about to get married, heading off for her bachelor party or bachelorette party, whatever. And she wants to go to Rome, as Chris has suggested. And my bet is that she will be able to do that on a zero-emission airplane. And now you can, again, fill out the poll if you want to bet with or against me, but I won't react to it because, as you might have guessed, we as a company, as ZeroAvia, we bet our entire company on that, right? We think zero-emission aviation is something that clearly needs to happen. And what we want to be is the first practical zero-emission aviation company. And that means, not looking at 2050, which is what I have just done, granted, but actually look at what's really practical by mid-decade, and then, by 2030, what can you actually commercialize along these timelines? And that puts us at somehow, the different end of the spectrum to what Chris and his team is looking at, which is both very, very important parts of the whole story to get aviation to net zero. Because to net zero, we must get. And if you look at where we are today, we don't really have a solution of getting there. I think market-based measures, as they're nicely called sometimes, is kind of agreed on by everyone that is not going to get us there. We have 5 to 10% of actual climate impact today in aviation, or 2019, and that might grow up to a quarter to 50% of total human climate impact. And clearly, we need to start now because of the useful life of commercial aircraft, and we need to actually start building those truly scalable solutions. Now, the way we plan to do that is that we believe in hydrogen electric aviation, renewably powered hydrogen electric aviation, to be precise. Now, hydrogen electric, what does that mean? That's what you see here on the right-hand side. You take hydrogen stored in hydrogen storage tanks. Initially, that will be gaseous. In the future, that will be cryogenic liquid hydrogen. You put that hydrogen into a fuel cell system where it gets combined with oxygen from the air, and that reaction creates water and electricity. And with that electricity, you create or propel electric motors and propellers. The reason we focus on that, and specifically on the propulsion system, is that we think that is the true bottleneck for sustainable aviation. We think we build great airframes. We think we have a lot of the kind of infrastructure solutions is actually there. We think the true bottleneck is the propulsion system. That's what we aim to provide. Now, when you move to hydrogen electric aviation, there is not only the propulsion system you have to change, you also have to change the ecosystem around it. And that's where we look at electrolyzers, and which split water to turn it into hydrogen and oxygen, and where we look into renewable electricity solutions to actually power those electrolyzers. All of that results in long range, low cost, and zero emission solutions. The great thing about it is that the momentum for hydrogen aviation has been accelerating tremendously over the last year or so. So ZeroAvia, we're about a 3-year-old company, and 3 years ago we had to explain people why sustainability in aviation even mattered. Then we had to explain people why batteries are not going to solve everything. And since that Clean Sky report in May 2020, really hydrogen in aviation is back on the agenda. And you saw that in the announcement that France made when they bailed out Air France, and in the support that they give to Airbus. You saw that in Airbus's announcements themselves back in September when they announced their Zero-E concepts. I can see that in trade publications like Aviation Week. I can see it even in your responses here, right? Looking at hydrogen, taking up 2/3 almost of the answers to Chris' question previously. So that's really, really exciting that this momentum is accelerating, and it helps us. But the key question now is, how do we actually do it, right? How do we make it practical now by mid-decade, as I said earlier, as opposed to talking about 2030, 2035 concepts? That's our core challenge. That's what ZeroAvia is all about. And we think there's 3 components to it. We want to inspire people by demonstrating what's commercially meaningful already today. And that's what we're doing in the Piper Malibu that we're flying at the moment. It's the largest hydrogen electric airplane in the world as of September last year, and we're getting ready for a 300-mile flight on it to actually demonstrate reasonable distances as well. And through that, right, like we want to inspire the public, but also within the sector and within the workforce to show that this can be done, because it needs to be more than just one company doing it. And we're seeing that happening now slowly. The second step is then to scale it. The 6-seater is clearly, not meaningful in itself. It's meaningful because it's a stepping stone to something larger. So we're looking at kind of 1919-seat turboprops, the sub-regional sector next, actually having a commercial product on the market by late 2023, early 2024. And then you move into the regional turboprops towards the end of the decade. And that is really what we are excited about. And then, of course, we move into like the Jet Zero or FlyZero programs that Chris is talking about towards the end of the decade. And the last thing is, you can only be practical if you have partners along the way, right? And that includes a supplier base, that includes working with the regulators, because nobody has ever certified a hydrogen electric aircraft before. And of course, it includes financing, like somebody actually needs to pay all those development costs. And that's something that we hope to bring together. So let me actually walk through each individual step here a little bit with you and give you a little bit more background what we do there. The first one, quite simply, we were flying the world's largest hydrogen electric aircraft. It was part of the High Flyer 1 program that we're doing together with EMEC Intelligent Energy here in the UK. We flew the aircraft out of Cranfield, and because I don't have to talk about it, I actually brought a little video. I'll just play that.
ZeroAvia is revolutionizing aviation by building a new generation of zero-emission powertrains for aircraft of all sizes. So we're hoping to become one of the major engine manufacturers for the new sustainable aviation.
Apologies once again. We seem to have lost Julian for a second there, the joys of technology, but we'll see if we can get Samir and Chris back for a bit of a chat whilst we're waiting for him to reconnect.
Can you hear me, Chris?
Yes, I can, Samir.
Chris, I was just looking through the questions and kind of re-paraphrasing and combining some of them, but I thought I'd start off with my own while we give Julian an opportunity to come back. In terms of what do you kind of see as the role of airlines and passengers in this transition towards more sustainable aviation? Do you think people will want to fly as much or in the same way? And how are you able to kind of factor that into some of the concepts you're developing?
Well, we see people who are flying going forward are one of the key contributors to what FlyZero needs to do, because if legislation changes and taxation comes out about carbon, numbers or carbon usage, then they will have an impact on the vehicles that might be out there in the future. So we are looking at that aspect as well. So we're trying to bring in the the users as well as industry as well as governments. So it all links is the way I describe it.
Okay, and is that through a kind of a modeling approach, or is it much more qualitative than that? It's
probably in the defining stages at the moment, Samir. We recognize we need to understand it and at least get a feel for what that might be, but we also need to understand from governments what sort of legislation or regulations might be, because obviously flight shaming, should we call it, is been out there, and clearly we want to see how we can actually bring that back to say people can go flying and don't feel that effect.
And they can do so responsibly and in an environmentally friendly way. Absolutely.
Yeah.
Looks like we've got Julian back. Julian, can you hear us, or are you still having internet problems?
His eyes moved.
His eyes did move. We'll carry on, Chris.
Okay.
And sticking with that kind of what the future market starts to look like, have you been able to kind of factor in where geographically aviation growth is going to come from in the future? And has that factored into your thinking in terms of what the flying public or government or regulations or legislation in those areas might start to look like? Because while we're driving the kind of net zero agenda here in the UK, perhaps further east, it might not be quite such an imperative.
Yeah, that's a really good question, but we're not focused on that at the moment. We are focused on the vehicle and how to get to zero carbon emissions, and that is our only key requirement. I think it will have an impact on maybe what does market sectors look like, or what do vehicles do, and that's something we'll hope will come out of our study, because our study is going to be around trying to obtain those facts and figures so that people can actually understand them and say, okay, I can support that argument, but also to create maybe the open questions like the one you're suggesting that needs further work. But I think globally what might happen in aviation is certain areas might run at different speeds. Okay, so maybe the higher developed countries might push ahead sooner. And you can see that now with Norway already saying we're going to have electric flight by 2030.
Okay, so you think it's the best approach is to strive for that zero emissions aircraft and flight, and the market and the world is likely to catch up at some point.
Yeah, I think you know, the emotional issues we can see out there with people flying is definitely on the agenda, and I think it's something we, you know, owe it to our children to sort out.
Right back to where Julian started his story. Julian, have we got you back? You want to give us a wave?
We can try.
Go for it. Go for it. Chris and I will exit stage, and we'll carry this on a bit later on.
Sorry, when I got a notice from my internet provider this week that it was going to be a weak connection this week, I didn't know it was going to be that weak, but let's see. So I'm going to be assuming that you heard me talk through this. So let me get to the scaling part, because that's where it gets exciting, right? Like kind of what's on the roadmap next for hydrogen electric aviation. I already spoke about the late 2023, early 2024 entry into service for kind of sub-regional aircraft with a hydrogen electric propulsion system. And we have just announced in December our HiFlyer 2 program, which takes the learnings from the 6-seater and scales them to a 19-seat propulsion system. So you're moving from something like 250 kilowatt to 600 kilowatt. And we're moving from kind of experimental aircraft towards a certifiable configuration. So that's what we're working on at the moment. And from there, the next step that we see is clearly in the kind of regional turboprop sector towards the end of the decade. And then towards like the 2030s, right? We're talking about the FlyZero, Jet Zero ambition that Chris has already spoken about. So we can talk more about that in the panel session afterwards, just so that we don't get interrupted by another internet shortcut here from me. What I did also want to speak about, right, is what I promised you earlier, is the support ecosystem that we need to build. So we have also in December announced our first official funding round. So we closed our Series A round with a couple of fairly well-known names. So Amazon Climate Pledge Fund, for example, Bill Gates, Breakthrough Energy Ventures was one of the lead investors, but also people like Shell, who know a lot about aviation fuel, clearly, and know a lot about hydrogen. People like Summa Equity, who is based in the Nordics, where clearly the early uptake will likely be. And also kind of investors from Hong Kong, for example, to cover that broad scale. And it's important, right? Because it is not cheap to develop the technology and to certify it. So you need financial backing that can actually support you on that journey. But similarly, you don't not only need the investors, you need partners on the airline side. So we've announced a partnership with British Airways earlier this year. You need partners from the industry ecosystem. So both Starburst and Elemental Accelerator are very well-known accelerators really around the world in terms of sustainability and aviation. And of course, you need the partners in the supply chain. So everything around our program HiFlyer here is about building a UK supply chain for hydrogen electric aviation. So if you or the company you work for do products in our supply chain, so electric motors, inverters, something out of the fuel cell balance of plant, if you have great heat exchanger concepts, if you do great hydrogen storage tanks for that matter, that would be great. Please reach out to me. You'll have my email and at the end of the presentation, and I'm sure you'll get the slides anyways. So do reach out. We do need to do this together. It's not possible to do it alone. And luckily, especially here in the UK, we also do have politics leading the way. So the Jet Zero Council was, of course, launched in the middle of last year. So that, I think, gave everyone in the industry a good ambition to work towards, and we're part of that. But also with bodies like the ATI, right? There is actually a lot of government support for industry to make this happen. And even the CAA is very much on the forefront of all of this and looking into it. So we're excited. We're quite excited about being based here in the UK. We started the company 3 years ago in Silicon Valley, as I mentioned, and now being here in the UK is quite fun, and it's great to build this ecosystem with everyone. So really, at this point, right, I'll be heading back to Samir, and I'll just say thank you, and look forward to the panel questions in the hope that I can actually listen through them.
Thank you for that, Julian. We'll just give it a few seconds for Chris to come back on stage. But while Chris does that, I think I guess another kind of a technical question for you, Julian. In terms of hydrogen fuel cells, is there a sweet spot in terms of altitude that these systems would be optimally designed for, or do they cut across the range?
So altitude, when you started with, is there a sweet spot? I was expecting like, aircraft size or something, because there's probably one there as well. But in terms of altitude, that's one of the key challenges, because in a way, right, a hydrogen electric system is also an air breathing machine. Like the fuel cell requires oxygen to function. So far, we don't see any fundamental hurdles coming from the altitude. There's probably other challenges that come with altitude that are bigger to solve in the near term, and before you get to the compressor challenges.
Understood. And in terms of some of those other challenges, I'd like to kind of dive into kind of some of the technical barriers we might see in both the projects that you're looking at, Julian, but also the wider alternative solutions that Chris and his team are looking at. We often hear about thermal management, fuel storage. Where are the real big leaps needing to be made to make some of these concepts a reality? If I start with Julian, from your perspective in terms of the hydrogen fuel cell concept, and Chris, maybe we can go more broader with other architectures.
So look, there's a near term and there's a long term challenge in all the areas that you said, right? Like kind of, I'll give you the near term answer, and then Chris can probably take on the long term one, because we probably have similar views on that. For us in the near term, right, like what do we need to do to get that 19-seater into a certifiable configuration of flying? And for that, right, the key challenge is thermal management. You have a lot of waste heat that you create because your system is, right, it's more efficient than a turboprop, but you still have waste heat, and that at relatively low temperatures, because it's low temperature fuel cells, so it becomes more difficult to reject. And most of that you have to reject at takeoff, where you don't have much airflow and stuff like that. So thermal management, absolutely. The second big challenge in the near term is absolutely also fuel storage, because it's quite a specialized area. And our initial target is gaseous. I already mentioned that 350 bar gaseous compressed hydrogen storage, which has a decent supply chain. But even there, it's a handful of companies really who do that well, and to do that, in a structurally sound way. Once you then move into cryogenic hydrogen, you have challenges on both the technical and regulatory side, but we can get to that in a second. And then the last one is really power density around the fuel cell system itself, improving that through the stack design, but also through the balance of plant components. So think, humidifiers, compressors, coolant pumps, all this kind of stuff.
Chris, over to you in terms of some of the architectures you're looking at. Where do you think some of the big leaps need to come in?
Well, so, we're looking at all the options out there, as I've said earlier, because we're taking it from an independent view. So we're looking at hydrogens to either burning those in a gas turbine engine, or actually creating electrical power from it through the fuel cell and running electric motors. And actually what we're looking at is those overall system performances, and we're comparing the, as you rightly say, Julian, the energy density to the weight of these structures, and then trying to predict, I'll call it the optimum solution, depending on the range and payload of the vehicle. So we're completely focused on the broadest spectrum you can think of at the moment, to try and then determine what are the sweet spots for each of the payload and range conditions you might think of. My view at the moment is we might end up with a hybrid answer, just to get certain key performance capabilities out of the types of systems, either using hydrogen or battery, or even a mixture of hydrogen and some of the other types of fuels. But I don't have an answer today. I'm still working on it. But I think it's a big challenge. I think the thermal issue is also a big challenge. And we've started to look at those sort of questions. And then also the location of this equipment to the motors, and that is very key, because obviously the weight becomes dominant by all the fuel and all the systems capabilities you need to feed in from the whatever it is to the engine. And then finally, the overall power management of this whole infrastructure, which again is unique. So lots of challenges, which is what's so fascinating about it at the moment. I think it's, I don't think anyone has a definitive answer. I think Julians have got a really good answer in what they're doing, but I think we're trying to find what are all the different types of answers, and hopefully can feed that back into the UK community.
Chris, it's a good point you made on kind of the wider infrastructure requirements, and maybe that dovetails into a couple of questions we've got from the audience. So if I start with the kind of airspace as a piece of infrastructure, and then go into kind of ground, in terms of airspace and the altitudes and the missions you expect some of the concepts to be flying, in your case, an actual aircraft, Julian, is there much change that needs to be happening on the airspace side to enable your vision of what aviation should be? I'll go with Julian first, because you've got a more of a concrete project on your hands.
It's a good. Sorry, echo.
Yeah, I can hear you.
Okay, you can hear me. Look, on the airspace side, right? It's an interesting piece, because the sub-regional sector, right? This kind of like less than 20 seats. It already today doesn't fly higher than 10,000 feet, essentially, just because most of the existing 19-seat aircraft are unpressurized, so it becomes very uncomfortable for the passengers to fly higher. Within that, right, like we do actually work with some airlines that want to grow this sector quite significantly, because they see an opportunity, right, with zero emissions technology coming in, with those being better from an operating cost perspective, to actually open up new markets in the sub-regional sector. So it's a lot of the kind of, more point-to-point operation, more connectivity, more frequent services. And for that, though, I don't think there needs to be changes in airspace. At least kind of, for us, that's definitely a focus. There's other infrastructure challenges that are bigger for us.
Thank you. And Chris, I know your project is looking at kind of the whole kind of system of systems and how all of that interfaces. So clearly, some of the concepts that you guys will be investigating will have, optimized flight paths and routes and altitudes in mind. Do you see a need for the change in the way we operate our airspace?
We do, actually, and the team is looking at those sort of scenarios. I mean, one of the things we're looking at, and there's a very good company in the UK looking at it, which is contrails and flying, and ensure we don't produce contrails, because that actually produces a fairly high percentage of CO2 as well. So we're trying to mix all that into what should the future aviation sort of flight cycles be, which will obviously be a challenge for the global community, because obviously aerospace being outside, it's a global. So how do you make sure you apply that across all the regions? And then to answer your other question about the actual airports, we are looking at the architecture at the airport in terms of what would be required if they need to, say, have a hydrogen storage area or an electrical power system, just so that we understand those impacts on the ground as well. So we're trying to look at all those aspects, and Samir, we may not be able to answer all those questions in the short time we have, but at least we'll hopefully identify them.
And Julian, same question to you. Have you worked with airports and airfields to start understanding what they might need to have on the ground to enable your kind of aircraft, and how much progress have you made along those lines?
So for us, there's a sequence of steps, right? So we were producing our own hydrogen on site at Cranfield Airport today. So clearly there's been like some work going on with the aerodrome there. And we're also looking to actually set up similar infrastructure at another airport in the next 2-3 months, which shows a certain degree of kind of repeatability, right? So kind of you kind of can convince airports that hydrogen is actually no witchcraft, right? There's safety procedures, and there's kind of workshops, and then hazardous workshop that you go through, and at the end of it, it's a safe fuel. So that's one of the key targets that we have in all of this, right? Show that it's a safe fuel. The second one is it an economic fuel? And that's kind of the next stage almost in our work, right? Is to now work with the actual kind of future sub-regional hubs in the UK and abroad, right? Like where you would actually start introducing those 19-seat aircraft commercially. What kind of is the most economical way to produce hydrogen? Our opinion is it's most likely actually producing it on site, because you get enough gravity from your infrastructure simply from aviation itself, just because, you know, an aircraft is kind of like the largest hydrogen user you can think about in a transport setting. But then you can complement that with, you know, trucks or buses that would also go to these same airfields. And then, you know, we're no longer talking about like Cranfield Airport. We're talking about something like Glasgow Airport or Bergen Airport, or, you know, some of the kind of like outer LA airports, stuff like that, where you really get sufficient scale in your hydrogen production to then get both, you know, a safe and a cheap fuel, which then starts drawing airlines into the product. So that's the way that we are thinking about it, kind of, you know, going through those stages. And people with the HIL, for example, Highlands and Islands airports, they are part of some of our future flight programs. There's a lot of discussions going on, and we work with a lot of infrastructure partners as well.
Excellent. No, thank you for that. Changing tack ever so slightly. You know, a lot of what you guys have talked about are kind of 5-10 years in the making before you're ready for fully commercial at scale operations. What is it that you want to see from the supply chain today? How can they start readying themselves for this future when it is quite unclear, particularly through some of the work that FlyZero is doing? We don't know what those future configurations and optimized airframe energy configurations might look like. What can the supply chain start doing from now to make sure they're ready to adapt? Chris, if I start with you.
Okay. I think it's really important the supply chain is looking at what the components of these possible solutions are, and developing either materials or manufacturing processes that would enable us to use them to manufacture those types of components. Investment in digitalization and things so that they can rapidly prototype will also be very important. So there's a lot of investment needed in some of the supply chain areas to actually support. What FlyZero is going to do is look at the industrial landscape and try and build those families of companies that could work together to make things like fuel cells or electric motors or whatever we deem is what our solutions are. And there are several companies already in the UK doing this, which is great. And hopefully we can then help drive that investment needed to make those companies mature and get to their products to be certified for a flight on an aircraft.
No, thanks, Chris. And Julian, from your perspective, you've got aspirations to have commercial flights into the market quite soon. What's your approach to kind of supply chain development?
So our approach, it's twofold, really, and that's kind of like, you know, the message probably to the supply chain broad, like just what Chris was already saying, right? It's like if think about the kind of what Chris already said, right? Like think about the systems that go into like the propulsion system, or in Chris' case, right, into like the whole aircraft, and kind of at which level you want to play, and then have a plan of how you get from where you are today to a certifiable product, right? Because like in the end, the actual like certification process at the moment is still relatively open on who takes what responsibility. But what you need to have is kind of how do you go through, right, like kind of a prototype stage and kind of however many stages that needs to be, and align that with the people who are working on the technology, like in that case, ourselves, right? Like we are not going from zero to a certifiable configuration, because there is, even in the, like small aircraft, there are just too many technological unknowns, right? There's things we just cannot know at this point, but we're aware of that. So we have a pretty practical approach to iterating through different configurations. It'll be at least 3 until we have a certifiable configuration for the 19-seater. And if you're part of the supply chain, right, we want to make this journey with you. So ideally you come on board now, right, and not in kind of 2 years' time and say, well, I have a great product here. That's kind of the biggest thing. And then back to, very at the beginning of what I just said, I said there's kind of like 2 ways to think about it. It's, if you already know everything about like aerospace and part of the aerospace supply chain, right, that's great. But also if you come from outside the aerospace sector, there is probably a role for you to play. But it's needs to be a kind of very conscious choice, right? Of actually, do you want to sign up for like becoming part of an aerospace supply chain, or do you kind of actually rather want to kind of stay in automotive or consumer electronics, wherever else your current focus is? Because it is different, and I think some parts of the supply chain just you end up wasting time for yourself and for everyone else if you kind of just want to explore for half a year and then you realize, wow, I just spent, I don't know, 100K on exploring, and then it's that would be my advice.
Chris, I guess a follow-on question for you to comment on. I've almost got this vision of a poster on you with you on it saying your aerospace industry needs you. In terms of the kinds of ways of working with the supply chain that FlyZero might look to try and almost create a funnel for interesting technology that might fit within your stack in the future. Have you got any indications at this stage as what that might start to look like?
I'll just make sure I'm answering your question you're asking me, Samir. Are you asking me about, do I have a way of going out there and finding specialist knowledge out there and trying to then get them engaged on FlyZero?
I'd go the opposite. If somebody feels that they've got a solution which they think might fit within your aspiration and ambition that you presented to us, what's their way of getting in?
Well, it's just literally approach us. I'm very open to look at any opportunities. I've told my team that we want to push all the boundaries on all the different technologies. So if someone has an idea that looks like it can have legs, let's say, we're prepared to consider it and look at it. And if it does, then obviously involve them in terms of, can we make it something that's value to the UK industry? At the moment, as I say, we're still building the team, and we're still coming up with solutions for what we think are the problems. But at the same time, we're trying to push the boundaries. So I genuinely, if there's someone who has an idea that has got some logic and it would work to get to our mission, which is purely focused on zero carbon emissions, then please pick up the phone, send us an email.
That sounds great. It sounds like both of you are open for business. Again, just sort of changing pace just a little bit. In the past, we might have expected some of our technology breakthroughs to come from the defense or the military sphere. I think what we're seeing now in the kind of shift is a lot of the technology is coming in from other sectors, consumer sectors, for example. Irrespective, that whole mission for net zero isn't just one that's aviation and aerospace, right? It's going to be economy-wide. Globally, that's where everybody is headed. Do you see kind of collaboration with military aviation, bearing in mind they're kind of heading in that same direction? And what do you think those opportunities look like? I'll start with Julian.
Look, in essence, right, like there's probably like the easiest link, right, is that the military already today is looking to buy like small electric kind of 2-seat trainer aircraft. So there is and that those developments come from the civilian aerospace, if you will, right? So I think there is like an obvious, at the moment, there's an obvious kind of pull from the military for some of these technologies. Will they be wanting to use a lot of what kind of Chris is thinking about in the future, most likely. Some of those things are also interesting, mission capabilities. If you think about, being able to produce your own electricity with like a flexible solar panel in the, I don't know, Afghan desert. Similarly with producing your hydrogen, right? You can do that suddenly on site. You don't have to keep a fuel supply chain going. It's like, things like that, right, is I think where military will pick up on it and is picking up on it. I know that the Royal Air Force has a sustainability strategy, or is building a sustainability strategy. What our role in this will be, I can't comment on, but I'm sure there will be a lot of kind of technology interchange.
Yeah, I imagine the military could offer in interesting test environments as well for some of these aircraft as well. Chris, I wonder if you've got a view on civil defense collaboration in this space.
Yeah, well, I sort of agree a lot with what Julian's just saying, where the military side is already sort of trying to absorb some of the smaller electric vehicles. But I think in general, the military side will take some of our data and our sort of systems and probably looking at applying it. And vice versa, we're talking to the military about, they have some software design tools and things like that, which might be of value to accelerate our processes. So when you're looking at whole aircraft design, it's a capability that is limited around the globe, and I think trying to share some of that is really good. This is purely from a UK perspective at the moment. Obviously, the military is driven by a lot more different requirements than us. They're quite happy to go up and burn a lot of gas and make a sonic boom. We're trying to do the opposite. So, I think there will be a coming of the ways. It's a timing issue again, and obviously, with the importance to fight climate change, I'm sure the governments will be keen to make the military as efficient, but also as sustainable as possible. So I'm sure it will happen.
No, thank you. Societal embracement is something that I'm a huge believer in, delivering to the public the kinds of products and services that they want. But hydrogen in particular comes with it. Interesting challenges from a public acceptance perspective. What do you kind of see as a roadmap of taking the public with us on that journey as we develop these? Because the last thing we want is to have a zero emissions aircraft in the market that people are afraid to fly on because it says hydrogen on the side, right? Not that we'll get to that place, but Julian is probably more front and center with you guys, and I'm sure you've thought about it. Have you seen a reluctance from any public engagement that you've done, or have the general public been quite embracing and warming of hydrogen flight?
So, look, I guess you can tell, right? So I'm German, so whenever I talk about hydrogen aviation, there's a very, the way I can tell it's becoming less of an issue for the public is that, when we started off like 3 years ago, and I've been with the company pretty much since the start, and the very early interactions we've had, it was literally the first question I got asked every single time. By now it has, we spent like already at least 20 minutes on this Q&A and it has not yet come up. So that's the first thing. Wait
for the Brexit question, Julian. Wait for the Brexit question.
That's true. But honestly, right, that's like number one, what makes me confident. Number two is, and that's a little bit, the first part of what I was talking about the inspire question, right? Like you need, like, show people that it's happening, show people that it's like an opportunity, and like that it is safe for that matter, but also really, right, like the way that we see us going to the market and working with the airlines is actually going through a lot of demonstrations. And in these demonstrations, right, bring in the public, have them, look at the airplane. It's one of the reasons why we, deliberately, like our airplane is like, looks like any other airplane, really. Like you couldn't tell it apart. Just, it's quieter and has a bit of water running out of it, but that's really it. And that's really kind of the interactions that we see with the public, and that we absolutely need to make sure, right? There's absolutely no use when in 4 years you can actually fly zero emissions, but then people say, oh, but it's hydrogen, I don't want to be on the next, Hindenburg.
Yeah. Chris, I won't challenge you with the same unfair question, but we talk about kind of safety being a key driver, ever was, ever will be for aviation. In terms of the relationships you guys have sparked up with the regulators, both here and abroad, any commentary in terms of how you're bringing the regulator along this journey with you? Chris, I'll start with you.
Yeah, I mean, we're involved with talking to the CAA, and hopefully getting them on board to support us with the questions that we're coming up with. So, because we need to understand what those legislations might be, we need to understand the regulations. So it's very important to us we do, because you can look at these devices, whether it's hydrogen or a battery, they all have risks associated with them, flammability or fire, and you need to have the answers. And I think the key thing about aviation is we're going to find the safest solution. But when I say that, the safest solution for hydrogen or for a battery, because that's what aviation is about. It's about flight and safety, and they go together. And I think if if Julian's aircraft can show that it can produce less CO2, that's going to be a bigger seller, because the safety bit is going to be a given.
Julian, I imagine you agree. So the slightly more challenging question, I guess, is around how have you found working with the regulator in the UK compared to, say, your US markets? Who's more forward-leaning? Who's got a better way to take the appetite for this risk?
So first of all, right, like 100% agree with what Chris said, right? Like kind of whatever comes to the market will be safe. It will be the safest option for hydrogen electric in our case, as Chris said. In terms of working with the regulators, because we started in the US, right? That means we have been having quite active conversations with both the FAA and the CAA, the UK CAA. We have even flown, right, kind of zero-emission airplanes, both under FAA permit, special airworthiness, and then in the UK under special airworthiness from the FAA, and then in the UK under actual kind of UKE conditions. So we've gone through quite a few kind of hoops with the regulator. I would say generally, right, it is easier to get something flying in the US. And that's because of a different approach that the FAA takes in the way it gives you kind of this initial special airworthiness. It's also the reason, frankly, why you have seen something like, the Magnix Caravan flying in the States and not here, right? I think kind of, there is just that bit of different approach that makes it a bit faster to get something up in the air in the States. On the other hand, right, like kind of what we have found now here in the UK is actually that things like e-condition, stuff like that, yes, they take more effort, they require more documentation, they require more thoroughness. But what that means is if you fly something here, you're already further down the journey towards a certifiable or kind of something that's actually like a more meaningful demonstration. So, both have their advantages and disadvantages. It's great that both exist. That's kind of my feeling about it.
Okay, no, very good, Julian. Sort of coming back again at a slightly helicopter view, you guys are both involved in predominantly in terms of the vehicle, the flying vehicle, the aircraft, right? In terms of perhaps positioning a different way of flying rather than one massive long haul hop versus a half a dozen short haul hops, if that gives you the environmental benefit. Do you see enough work going on in terms of changing that overall kind of distributed aviation network and architecture? That might be a better way to fly, but it might be slower or slightly less convenient because you've got more takeoffs and landings. Do you see a shift in the way people expect to fly in the future? I'll start with Chris.
I think it's a really good question, and I think it's something that our team are talking about now, because perception is that these vehicles won't be able to fly as far to give us the zero carbon emissions that we're looking for. So then you would end up with a bit of hopping to small, along the way. So it will take longer. But I think from an emotional point of view and also protecting the planet, I think there will be people who accept that, because they won't be spending all their carbon coupons, if I can put it that way. So I think one of our objectives within FlyZero is to try and look at what that market might be once we've come up with some views on the vehicles, and then trying to determine what does that mean. So I don't have an answer correctly, but
no. I think it's a great answer, and it's great to know that those conversations are taking place. That we're looking to, potentially overhaul a much wider system, not just from an aircraft or an energy perspective, but there's a wider conversation to be had. Julian, with your aircraft, no doubt your design parameters were fed by a series of use cases and missions that you had in mind. Where do you kind of see those markets?
Yeah, so like what we always talked about was like a base case kind of in an expansion case, right? So we said, look, kind of there's one world in which, you literally just go and replace the existing fleet and kind of existing emission profiles, right? Where like already for the 19-seater segment, kind of 95% of flights are less than 300 nautical miles. So that's kind of your design point. But there is also through that, right, and through kind of better economics because of potential reduction in fuel and maintenance cost, there's then an expansion case, right? Which is a little bit, that's what you're pointing towards, where you say, well, actually, if I now can fly cheaper and greener and quieter, what kind of networks do I unlock with that? And I think the way that will, and that will happen with a 19-seater, that will happen with a kind of turboprops, so it will happen with jets, as Chris says, right? As say, you can fly 120 passengers, but only, I don't know, 1,000 nautical miles, then that will change the network. I think what will happen, and that's what we're seeing actually in a lot of the supply chain that we're working with as well. So it's quite interesting that it comes both up and downstream. As people push things, these questions pop up, and then there is new people pushing these things and think about how can I now do kind of the network differently. So if we provide answers to some of the questions on the aircraft side throughout all the different sizes of aircraft, people will come on the network building side and start asking exactly those questions and actually giving you answers and start proving the hypotheses in the same manner that we're doing it on the technology side, on the network side, right? And some of those will fail, some of those will succeed, and that's great. But in the end, I think that's how you will actually see change happening in all these things.
Absolutely. And do you both kind of broadly buy into a current UK industry sentiment, I guess, with the longest range flights, if that's the paradigm we want to stick to, is going to require some kind of kerosene-like synthetic fuel? Or do you genuinely believe that your technology could scale up to those largest segments? Chris, you probably don't have the answer yet, so I'm sure FlyZero will be asking exactly those questions. So from Julian's perspective, is there a limit to where you feel as a primary propulsion source your technology can get you?
Yeah, look, I think I think Chris gave the answer. So I'm gonna copy Chris here, but essentially, the longest flight and the largest airplanes will have to be carbon-based fuels. Let me put it that way. I think that's kind of commonly accepted at the moment. I think the key challenge is, you said it right, like in this paradigm. So right, like what if something changes? Then we might see.
Yeah, no, that's a great point. So my last question is less of a question, but I'm going to ask you to put yourself in the Prime Minister's shoes. You're addressing COP26 in November. If you were going to say one thing in terms of what you were backing to demonstrate the UK aviation sector's credentials in sustainable aviation, what is it you would say as Prime Minister of the UK on that COP26 stage? Chris, I'll go with you first. Take your time.
Thank you for that question. I think the one thing I would try and say is that we're the UK's in a race, and we need to create the next generation of zero carbon emission aircraft. And to do that, we need to invest heavily in technologies and actually drive to some of those solutions. And that means building not only the supply chain to do it, but understanding the infrastructure needed around the airports and the operation of these aircraft. And it is a revolution, not an evolution, and will require a lot of input globally.
I'll decide who my vote's going to once I've heard from Julian. Go on, Julian.
Sorry.
For all the time while Chris was speaking, I was thinking about how can I finally make that Brexit reference here, because it still hasn't.
Yeah, that would have been.
No, look, I would. Let me push one point out of what Chris has said a little bit further, because I think if you want to push sustainable aviation, and that's clearly what the Prime Minister wants to do, right? And you have Jet Zero as your ambition. You need to support your local industry, right? You need to support leadership within the UK on certain elements of the supply chain. but at the same time, right, encourage global collaboration on the supply chain, because there is no way that every single component in a best of class product will come from one single country. It's just not how the industry works today. It's not how any kind of innovation has ever made it to the market by just, focusing on a single country's capabilities. And those two things together, right, like invest in UK leadership, but encouraging also looking outside your boundaries and kind of looking at what other people are doing and learning from them and working with them. Those two things together, I think, can,
making sure the UK is the partner of choice in this endeavor, I guess.
That's the way to describe it, Samir, definitely.
Yeah. Well, we'll try and vote for each other and see where we get to. At that point, it's probably worth bringing Alea back in to wrap up the event. We've got 5 minutes left. I'm sure she's got some closing remarks to make. Alea?
Yes, thank you so much, everyone. That was a hugely engaging Q&A session, amazing presentations, and really, really great session. Apologies once again for the couple of technical glitches there, but we got Julian back in the end. And thank you very much to all of you. Thank you, Julian and Chris, and thank you, Samir, for hosting. And of course, a huge shout out again to our sponsor, Nova Systems. Thanks, Tim, for your presentation and for sponsoring this session. Just one thing to add now is to look out for notifications for the next session, which is going to be on test and measurement in April. And until then, to continue the conversation in the Advanced Engineering UK LinkedIn community group. And we hope to see you all in person in November for Advanced Engineering at the NEC. But thank you so much, guys. It's been really, really great having you. And thank you to everyone who attended.
Thank you very much.
Thank you.